of this division. So I'm going to call this polynomial p of x. So all I have to do is with the graphing calculator, plug in this polynomial, plug in -2. If the answer is 0, then x plus 2 is a factor of the top. If the answer is not 0, then x plus 2 is not a factor of the top. So that's all I need to do. I will plug it in y equals, clear everything else, and enter 4x cubed. And then plus 5x squared and minus 6x and minus 4. And what I have to do is just plug in -2. And the answer is -4. So therefore, x plus 2 is not a factor of p of x. I use the remainder theorem. What is the remainder theorem? I plugged in the polynomial from the numerator, I plugged in -2. Because the answer was not 0, but p of -2 is -4, it means clearly that x plus 2 is not a factor of the numerator. Okay, that's all there is to it. So in this example, we used the remainder theorem and the factor theorem. The remainder theorem by plugging in the polynomial -2 and getting the answer. And the factor theorem, because the answer is not 0, we use the factor theorem to conclude x plus 2 is not a factor of the top. If it were 0, I would have concluded the opposite. Good. Next question. Anything else we want to look at?
Would we be able to use synthetic division on that equation as well?
If you're asked to find the quotient, yes, for this one. But if you're not asked to find the quotient, don't waste your time.
Okay.
And I just realized they already have the test for you. I just realized, don't get scared. By mistake, I wrote test 2, the title, but it's not test 2, it's test 3. My apologies. So don't get scared that they're giving you a wrong test. And there is nothing I can do right now to change that. I'm so sorry because they already have the test and I don't want to confuse them. My apologies. So in the title of the test, I wrote test 2, but it deals with chapter 3, so it's test 3, not test 2. Sorry about that.
You mean like on the paper?
Yes,
Test, what we do
yes, yes. It just says the title is test 2, but it's test 3.
Okay, so
disregard that.
When I go in there to get the test, are they going to ask me if it's test 2 or will they know it's test 3?
It's a very good point. I'm going to send them an email and let them know that I have a mistake in the title of the test, so they know. Yeah. It's a very short test. You have 2 hours. You have 6 questions plus an extra credit. Yes, you can be in and out, but don't. That's not the point. Good. I'm going to ask them and see if I can make the change and ask them to shred what they have, and so there is no confusion on either side. Good. Next question. Good. Anything else? Does anyone need help with the homework? Is there anything else you'd like us to go over? So what would you like me to do? Please talk to me. What would you like me to do next? We have roughly 25 minutes left. What do you need me to do? Hunter, what do you think? Christy?
I think I'm okay with the review now.
Okay. Hunter, what do you need?
Could we go over a few polynomial and rational inequalities?
Yes, of course. Would you give me any? It can be from your homework, from anywhere. Yes, of course.
Give me one moment.
Good. If you want, they are on page, this is section 3.6, 3.6, yes. They are on page 443.
Could we go over question 5?
Yes. From that page?
Yes.
Yeah, sure. 5, you said. The x squared minus 5x plus 4. Is that the one?
Correct.
Okay, perfect. Of course. So all I have to do is factor this into x minus 1 and x minus 4. I have a product or ratio and 0. I can use the table right away. X is the variable in the problem, x minus 1 and x minus 4, and the product, x minus 1, x minus 4. It's 0 at 1, it's 0 at 4. 0, 0, 0, 0. Because if either one of them is 0, it's 0. Both of them are lines with a positive slope, from negative to positive. Multiplying two negatives, one negative, no negative. Now it says positive, because only positive is greater than 0. Is the product ever positive? Yes. So the solution is x in the interval negative infinity 1 union 4 to infinity. Is this okay?
Yes. Yeah, that's good.
Perfect. If you want to choose a rational as well.
We do 12.
Yes, very good. Let's do 12. 12. 12 is not a rational. 12 is still polynomial, but that's fine. So 9x squared plus 3x minus 2 greater than or equal to 0. The first thing I do, I find see if the polynomial is factorable. I go to apps, I go to 9, polynomial root finder, degree 2, and 9, and then 3, and then negative 2. And I'll see the solutions. Okay, so the solutions are, what are they? 2/3, negative 2/3, and 1/3. So x minus 1/3 and x plus 2/3. Good. So let me explain one thing. So I solved the equation and I got x equals 1/3 and I got x equals negative 2/3, which means the factor is x minus 1/3 and the factor is x plus 2/3, because when you solve this, you get this. When you solve this, you get this. So I have the two solutions. All I care about, negative 2/3, 1/3, x minus 1/3, and x plus 2/3. And the product, x minus 1/3, x plus 2/3. So 0 and 0. Again, both of them are like this. I don't have to think. From negative infinity to positive infinity, from negative to positive. 0 and 0. Again, positive, negative, positive. Again, they want positive including 0 though. So positive including 0, this and this. So negative infinity, negative 2/3, union 1/3, infinity. So this is x in. Is this okay?
Yeah.
So now let's choose a rational. So these were both polynomial. Once I get the solutions, there is no issue. I'm going to write the testing center a note, apologizing for my error, and maybe they can correct it. So there is no ambiguity when you get there. Good. Did we find the rational? We have a rational inequality. Do you want me to choose one?
Yes.
Okay. I will choose 49. See if you want another one. If not, we'll work on 49. Is 49 okay? Yes? No?
I don't see 49 on my page.
On 443. Go to the next page. 443. The rationals are from 43 to 60. Do you see 43 to 60? I'll do 49 and then you can choose another right after that. Okay. So again, this is already done, meaning I have a ratio on one side and 0 on the other. Otherwise, I cannot use the table. I have to have on one side either a product or a ratio. Mandatory. And on this side, 0. It doesn't matter which one. But one side has to have 0 and the other has to have either a product, as we just did, or a ratio. It has a ratio. So I have x. In order to make sure that you don't make a mistake, always present polynomials in descending order. Don't let them confuse you. As the ratio, it doesn't matter. This is 0 at 2, and this is 0 at -4/3. So -4/3 and 2. At 2, because the numerator is 0, the fraction is 0. But when the denominator is 0, what happens here? When the denominator of a rational function is 0, what happens to the fraction or the rational function?
Becomes undefined.
Exactly. Exactly. That's mainly the difference between the product and the ratio. That's the main difference. Now this looks like this, which means it comes from positive, goes to negative, because the slope is -2. And this one is nice, no problem. I divide or multiply these two. I divide or multiply these two. I divide or multiply these two. And what do I want? Well, I want negative. I cannot include this but I have to include this because of the equal symbol. So negative infinity, negative 4/3, I cannot include it because it makes the fraction undefined, but this I have to include, which is 2, because of the equal symbol. So closed, 2 to infinity. So is this okay?
Yeah.
Okay. Good. Anything else? Is there anything else we want to look at?